Alright, this is page 2 of Review Worksheet, Chapter 6a, and I have a quotient here, and I notice there's a binomial in the denominator, so I know the only way to get this radical out of the denominator when in a binomial is to multiply that denominator by its conjugate by 2 plus root 7 in this case, and so of course I have to multiply by 1 to not change the value of the whole fraction. So I also know that the pattern is that when I multiply these together using distributive property, I'll get the first term squared minus the second term squared. So I'll get 4 minus 7, or negative 3 in my denominator, and my numerator will be, if I'm distributing here, 10 plus 5 root 7. And that really doesn't simplify. On your answer key, I know they've got this written as a fraction. They've factored out a negative 5/3. But we could just look at this as negative out in front, 10 plus 5 root 7 over 3. Okay, number 16, we need a common denominator. I'm going to first just change this. I'm going to simplify this 8 to be 2 root 2. So I'm going to rewrite that as 2 times the square root of 2. And now if I look at, I know I need a lowest common denominator if I'm going to add these two terms. And so my lowest common denominator is 2 times the square root of 2. So this is already over the LCD, and so this next term needs to be written in the form of 1 over 2 root 2, so I have to multiply that by 2. Make sure it looks like that, multiplying 1 in the form of 2 over 2. So I get 5 plus 2, or 7, all over 2 times the square root of 2, and then I can rationalize that denominator, multiplying by 1 in the form of root 2 over root 2. There's lots of different orders that you could have done all of these steps in. And still, as long as you simplify correctly. So root 2 times root 2 is 2 times 2 is a 4, and so I get 7 times the square root of 2 over 4. In number 17, same thing. I need a common denominator. I think on this one I'm just going to go ahead and rationalize this numerator first. This one's like over 1, this term. So I'm going to multiply this one by 1 in the form of root 3 over root 3. And so this one then will be, well, let's just look at it after I do that. So now I'll have, oops, that should be a root 3, 5 times the square root of 3 over 3 plus 5 times the square root of 3 over 1. So to get this over a lowest common denominator of 3, if I look at it now just as a 3, I have to multiply this by 1 in the form of 3 over 3. So now I'm going to have 5 root 3 plus 15 root 3 all over 3. So that is 20 times the square root of 3 all over 3. And again, different orders I could have done that in. I could have written these both over square root of 3 to begin with and then rationalized it at the end. Any order works as long as you're using the properties correctly. Okay, 18 and 19 are both good because we've got other than square roots in the denominator. And so in this one I need to get exponents down here in the denominator that are multiples of 3 in order to rationalize this denominator. So I have an x squared and a y to the first. So really my goal would be to get an x, the cubic root of an x to the third and a y to the third, the next highest powers of those variables going up that are divisible, or multiples of 3. So in order to do that, I'd have to multiply by the missing factors. For x, I would need 1 more power of x and 2 more powers of y. So, of course, this is just a big 1. So the reason I did this was that now in the denominator I'll have a perfect, xy, and in the numerator I'll have 5x times the cubic root of xy squared. So that's that one, and then we use the same property. Whoa, no, not done. X over x. Whoa, careful. X over x is a 1, so I really just have 5 times the cubic root of xy squared all over y. Okay, so 19. Let's see what we've got here. We have the 7th root, so I'm going to need multiples of 7 in my exponents in order to rationalize this. So again, my goal will be to get the 7th root of a to the 7th, b to the 7th, which are the next multiples of 7, going up from 2 and from 4. So then I would have an a come out and a b come out. So I have to multiply in this denominator here by the missing powers. So I would have a to the 5th to get an a to the 2 plus 5 here, and I need a b to the 3rd to get a b to the 4 plus 3 here. So this is a big 1. So I have a times this in the numerator, a times the 7th root of a to the 5th, b to the 3rd, and then I have an a over an a, which is a 1 that can cancel. So my final answer, simplified, is the 7th root of a to the 5th, b to the 3rd, all over b. Okay, going to number 20. I have binomials in my denominators. I think rather than try and rationalize those, I notice that those are conjugates. So I'm going to write my lowest common denominator here. It's going to be, these are different terms. It's going to be the product of these two conjugates. So the square root of x minus the square root of 2y multiplied by the square root of x plus the square root of 2y, which if I multiply those together, I know from the pattern that I'll get first term squared minus second term squared, so I will get x minus 2y eventually in that denominator. So at first thing I need to do is beef these up over the lowest common denominator. It's just adding fractions. I'm not solving an equation. I can't cancel any denominators. So this gets multiplied by 1 in the form of x, root x plus root 2y, and the square root of x times, or plus the square root of 2y. And then the second one here gets multiplied by 1 in the form of square root of x minus square root of 2y. So now it's all over the LCD. I'll just write it as LCD since I have identified it, and we'll put it back in what it is later. So I'm going to have, by distributed multiplication here, x times the square root of x plus x times the square root of 2y plus x times the square root of x minus x times the square root of 2y. So let's see, these two are opposites, those cancel each other out, and I get x root x plus x root x is 2 x times the square root of x over the lowest common denominator, which we already said was, it's the product of these two, but when multiplied together it's x minus 2y. And that's as simplified as we can go. There's no common factors or anything there that can be canceled. Okay, now we go to number 21, and this is the section where we're solving equations. So we're looking, if we've got, like this first one, number 21, fractions, we're going to need to, we can beef these up, rewrite them over the lowest common denominator, and then clear those fractions. So the lowest common denominator is 2 times 3, which is 6. So this one needs to be multiplied by 1 in the form of 2 over 2, this term by 1 in the form of 3 over 3, and this by 1 in the form of 2 over 2. So we've got, it's now, I guess, let's just multiply it by the LCD of 6, and I would clear all of those denominators. So I'll just have in the numerator 2 times 2, or 4, is equal to 15 times the square root of x minus 2. So we know that we have to isolate the radical term, because this is a radical equation because there is a variable under the radical. So I'm going to add 2 to both sides. Still trying to isolate this. I'm going to divide both sides by 15. So 6 over 15, this is 2 3s and 5 3s. So this is 2 fifths is equal to the square root of x. So now I know in order to solve, I need to, this is a square root, so I'm going to do the inverse of taking the square root, which is to square both sides. And I get 4 25ths is x. So that solution set is 4 25ths, and I will leave the check to you, but it does work. It's pretty simple arithmetic on that. But you would need to make sure it made the original equation true. Now, number 22, I know I've got to try and isolate this term first. So I'm going to subtract 3 from both sides. So I'm going to leave the negative root of this expression is equal to 8 minus 3, or 5. Right away, I know I've got a problem. When I don't see anything in front of a radical sign, it means you're looking for the positive square root. When I am looking for the negative square root of a number or a value, I see a negative in here. So if I'm looking for the negative root of something, it's not going to be a positive 5. Also, you know, if you just think about dividing both these sides by -1 or multiplying both sides by -1, we would have this. And again, you know, the square root we're looking here for the positive square root. It cannot be a negative number. So this problem and the fact that that's a positive, those are the same problem. So basically, there is no solution for this equation. And so I will just put the empty set. Okay, so let's see here. Our next problem, I'm supposed to find the value of k under the radical here, so I'm going to isolate this radical expression. I'm going to add 3 to both sides, divide both sides by 4, and then do the inverse of taking the square root by squaring both sides. So I get 100 equals 2k plus 6. So subtracting 6 from both sides, 2k then is equal to 94. So k is equal to 47. So you're going to want to check that in the original equation. So 37 is equal to 4 times 2 times 47 plus 6 minus 3. Well, this is 94 plus 6, or 100. And the square root of 100 is 10, and 4 times 10 is 40. So we get 37 equals 40 minus 3, which is correct. So solution set is just a positive 47. Okay, number 24. We already have the radical isolated here, so I'm going to, right, it's invisible 2 is the index. I'm going to square both sides. So we're going to get 25 is equal to 2 minus 3k all over 5. So multiplying both sides by 5, I get 125 equals 2 minus 3k. So continuing on, subtracting 2 from both sides, 123 equals negative 3k. Dividing through, I get k is equal to negative 41. So again, let's check this. 5 is equal to the square root of 2 minus 3 times negative 41 all over 5. So for this to be a positive 5, this whole thing has to reduce to a positive 25. So 2, that's 123. 2 plus 123 over 5. So 5 is equal to, that's 125 divided by 5, square root of 25. Oops, so that works. So the solution set is the negative 41. Okay, number 25, we have, we're solving for c. It's under the radical. It's in the numerator of both terms on the left side of this equation. Basically, we have fractions. We need a lowest common denominator, and that's going to be the lowest common denominator 5 and 10, which will be 10. So we need to beef up each of these up so we can clear the fractions. So this one needs to be multiplied by 1 in the form of 2 over 2. This is already over 10, and this needs to be multiplied by 1 in the form of 10 over 10. Now, if I multiply both sides by the LCD, I will clear all those denominators. And I'll have 2 times the square root of c plus the square root of c is equal to 10. So 2 roots of c plus 1 root of c is 3 roots of c is equal to 10. So the square root of c is equal to 10/3. So I'm going to square both sides, and I get c is equal to 100 over 9. That's a pretty simple arithmetic check. I will leave that one to you. The square root of 100 over 9 is always going to be 10/3, so 10/3 divided by 10, 10/3 divided by 5. You add those up, you should get 1. You can use your calculator if you'd like to check it. Okay, number 26, I'm going to solve this radical equation because I've got an expression under here with the variable. The variable's also out here, but the important thing is that if I'm going to square both sides, I have to wrap and square the entire side on both sides. So on the left, the square root, when I square that square root, the m plus 1 comes out. On the right, really, here, this means, of course, m minus 1 is a repeated factor. So I get m squared minus m, which is minus 2m, and then plus 1. So I'll leave a 0 on the left, subtracting m from both sides, minus 3m, and subtracting 1 from both sides, it goes away. So I'm going to factor this. I'll factor out the greatest common factor of m, and I get m minus 3. So my solutions are 0 and positive 3. Initial solutions. Now remember, it's so important to check these because you may have extraneous solutions. What happens when you square a square root is you might only be squaring the positive root, the principal root, but the answer you get is the same as if you would have squared the negative root, you know, a negative root of m plus 1. So let's look what happens. Let's check 0. So when we check 0, we get 0 plus 1 is equal to 0 minus 1. So this is the square root of 1 is equal to negative 1. Well, that's not true because the principal square root, positive square root of 1, is 1, and that is very much not equal to negative 1. That means I have to reject that solution of 0. So I want you to purposely show me that you got that solution and you purposefully reject it. And now I have to check the 3. So 3 plus 1 is equal to 3 minus 1 here. So square root of 4 is equal to 2. So this is looking for the positive square root of 4, which is a positive 2, does equal 2. So that one checks. So our solution on this one is just a positive 3. Okay, last two problems. So when I've got two radicals, two expressions that are radical expressions where the variable's under the radical in both of them. I have to do this process twice of isolating the radical and raising both sides to the nth power. So I'm going to add, I like to isolate the more complicated one first. I'm going to leave this one alone at first. So I'm going to add 2 to both sides just for starters. So these 2 are on the left, and isolate this, this one here. So I chose to isolate that one first. So the square root of c plus 16. So now I'm going to wrap and square both sides. So this is a binomial. So root c plus 2 times root c plus 2, you know, if you have to FOIL it out, you can, but by now you should be used to the pattern. This is the first term squared, which is c, plus 2 times the product of these two. So 2 root c, so it's plus 4 root c, plus this last term squared, which is a 4, is equal to, and this just becomes the c plus 16 comes out. So now we go in and we're going to isolate. This is like we just have to repeat the whole thing. We're going to try and isolate that radical term. So first thing is, if I subtract c from both sides, right, that goes away from both sides. And then if I subtract 4 from both sides, I will have 4 times the square root of c equals 12. So dividing through by 4, I'll get square root of c equals 3. And now I square both sides, of course. So c is equal to a positive 9. So I do need to check that. So I get, in the original, you have to check it in the original equation. So square root of 9 is equal to the square root of 9 plus 16 minus 2. So this is the square root of 9 is 3 equals, this is the square root of 25, which is 5 minus 2. So that one works. Okay, number 28, last one here. Already isolated on one side, so I'm going to square, and I'm going to wrap this binomial and square it. So I'm squaring the entire left side and the entire right side. Okay, so this is going to be a y squared minus 2y minus 2y, so minus 4y plus the 2 squares, so plus 4. So I'll subtract, I'll leave a 0 on the left. Subtracting y from both sides, I'll get a negative 5y. Subtracting 10 from both sides, I'll get a negative 6. Easily factorable. Okay, be careful with this. Y minus 6 and a y plus 1. Plus 1y minus 6y gets me my negative 5y. And negative 6 times 1 is my negative 6. So my two solutions are a positive 6 and a negative 1. Both need to be checked. So we'll check the 6 first. So here's a check. So the square root of 6 plus 10 is equal to 6 minus 2. So this is the square root of 16, which is 4, is equal to 6 minus 2. So that one checks fine. So I'm good with the 6. Now let's check the negative 1. So putting it into the original equation, negative 1 plus 10 is equal to negative 1 minus 2. So this says the square root of 9 is equal to negative 3. Well, that's not true for the positive square root of 9. There's no negative sign there. Okay, so they're looking for the principal square root of 9, which is a positive 3, and it is not equal to negative 3. So you have to reject that negative 1 as a solution. So again, circle it and purposefully reject it. And that's it for review worksheet for Chapter 6A.